Hello everyone, today I'm going to be talking about probability distribution functions, or we call them PDFs, and how they are used in statistics. Okay, so the first thing I think about when I hear about a PDF or when I see a PDF is just a function. It's just a function, okay? It's going to be a function with with a couple special properties that have to be true for it to be a probability distribution function. Okay, so when I'm saying function, they give you some y equals f of x, and in algebra class you had to graph these things. You had to graph these. So you could have got a function maybe that looked like this. Okay, and on probability distribution functions, I might be interested in this area under the curve, the area under the curve. Okay, so let's talk about the two ways a function becomes a probability distribution. Okay, so the first thing that has to happen is the line has to be above the x-axis, the x-axis. Okay, so what this means is that this is the x-axis here, this is the y. So in general, we want this line to be up here somewhere. Okay, we can't have it down here. The line can't be here. Or if it starts here and goes up here, we're only interested in this part right here and not this part here, not this part. Okay, so that's the first thing that has to be true. The second thing is the area under the curve. The area under the curve has to be 1 or 100%. And the area under the curve represents all of the data. The area represents the percent of all data. So let me show you a very basic example. So let's just say I have this histogram, okay? And it kind of goes like this, maybe like this, and like this, okay? So, and let's say it starts at 0 and goes to 3. So this could be like 1, 2, and 3. Let me clear this up a little bit. Or let me just say this, it starts from 0 and goes to 3, and okay, let's get started. The area represents the percent of all data under the curve. So let me just show you kind of like what a quick example of this would be. So let's say I have this curve and I have a line. My line goes like this and goes like this. Okay. So it starts at 0 and I'll say it ends at 5. Okay. And then I'll say the height of this is 3. So the length is 5 and the height is 3. And I could ask, is this a PDF? So what you have to do is you have to say, okay, are my two rules true? So look at the first rule. I'm looking at this area right here, the area under the curve. Looking at that area. Okay. So as a review, the area of a rectangle is length times width, so it's 5 times 3, which is 15. Well, since this is not equal to 1, this is not a PDF. Okay? It has to follow both of these things have to be true. Okay, so how about another example? Let's do the same thing. Here's your curve right here. Now let's say this is 5. What does the height have to be? What does this height have to be a PDF? Okay, so we want the area in here to be 1. Okay, so let's just call this y. let's call this y. So area equals length, which is 5, times width, which we don't know, or sorry, length, which is 5, and height, which we don't know, which we'll call it y. But we know that this times this has to equal 1. So just using algebra, I could divide 5 on the left side and divide 5 on this side and cancel that out. So this here has to be my height. Now this is a PDF. This would be considered a PDF. Okay, so let me show you how we use these in statistics. Okay, so I'm going to make a histogram. Okay, so if you look, this histogram is fairly symmetric. And let's ask a question. What's the area of everything under this curve? What's the area of this, all of these rectangles? Now we know from earlier work that this area equals to 1. So what we do in statistics is we want to model a PDF, because it's a little more difficult to work with this than area under a curve. So we want area under a curve. We want one of those PDFs. So what I'm going to do, let me change the color here. Let me change the color here and go with something you can see. Okay, so what I'm going to do is I'm going to cut through these guys. Okay. Alright, and what I'm going to do is I'm going to approximate. See, I have a little bit out of here, but then that cancels this out right here. Okay, and what I'm going to do is, just to make it a little more believable, I'm going to add one more there and one more there. Okay, so you see this little area out here? That will cancel out with this area. And this area out here, in here, will kind of cancel out with these areas here. Okay, so the process is that instead of working with histograms, I'd rather work with this model. Okay, and this is really your x-axis, and these are just numbers. These are just numbers. Okay, so the line is above my x-axis. The line here, this curve right here, is above my x-axis, and the area under here is equal to 1. We're just going to set it equal to 1 because it's approximately equal to 1. So if this happened to be 50, then this number here would be 50 right here. And they get bigger this way and less that way. Okay, so that's kind of what we use these for. And if our data is symmetric, okay, this would be called a normal model. This would be a normal model. Okay, and this model here represents all data. Okay, so that's a quick look at the PDF. Okay, and before I go, I'll just say PDFs could be any shape. PDF could be a triangle. PDF could be a triangle. Okay, so if I told you this length was 3, and I had to find what height this is, I would use the area of a triangle, which is 1/2 the base times the height. So I would plug all these numbers in because this area has to be 1. So the A has to be 1. So I just turn this around and say 1/2. The base is 3. The height is what I'm looking for, so that's going to stay as a variable, equals, and I know this A is 1. So I put that into 1. Okay, and then I would just solve it algebraically. I'd just multiply 2 here, and I'd multiply 2 here. Okay, multiply 2 on both sides, then these two things would cancel. Now I have 3h equals 1 times 2 is 2, and now I want to divide by 3 and divide by 3. Okay, so for this to be qualified as a PDH, this height has to be 2/3. Okay, so that's an idea of PDFs. We're going to be working with these PDFs, in particular this normal model, the whole year. So this is just get you an idea of where this normal model comes from. Thank you for watching. I appreciate it, and have a nice day.